Well, hello there, algebra students. Here's another Ms. Waite video for you, taking the next step down our little algebra road. We have talked about addition and subtraction for a couple of videos, and now we're going to tackle multiplication and division. And so let's get started right away. I hope you have your notebook out. If you don't have it, go get it. Pause the video and go get it, and let's get started. So I've got a warm up here for you. Another reason to pause the video would be for you to kind of dash out the answers to these problems. You can just pause me talking, solve these, simplify these, and then turn the video back on and we'll go through the problems together. All right, first one, 2 times 5. You know what it is, it's 10. Oftentimes we just know the answers to these things because we have so much experience with it that it just comes naturally. 2 times 5, everyone knows, is 10. Now look at number 2. See how there's that weird like asterisk between the 3 and the 8? That, my dears, is also multiplication. And so that sentence says 3 times 8, just like number 1 says 2 times 5. And what is 3 times 8? It's 24. Number 3 is also multiplication. Sometimes that's what parentheses mean. Multiplication can be a very confusing operation because there are lots of symbols that mean multiplication. But this number 3 is actually saying 10 times 6, which you know is 60. Now 4 is the first problem that we've had so far that is not multiplication. Whenever you see that little slash, 10 slash 5, I'll bet you already know that that looks like this. If you were turned it into a fraction, 10 over 5, or 10 fifths. Well, fractions are also kind of like little division problems, and so that can also be read as 10 divided by 5. And what is 10 divided by 5? It is 2. Sort of the opposite of the problem that we did in number 1. If 2 times 5 is 10, then 10 divided by 5 has to be 2 because they undo each other. All right, so these are some simple examples of what multiplication can look like, and also division. Sometimes the symbols are a little strange, and so we're going to use them differently. We're going to use them a lot, I guess is what I mean, so that you can get familiar with them. All right, here we go. But before we actually get to the math lesson, I cannot stress to you enough the importance of taking notes. Because you're going to be getting a lot of information and you're going to want to be able to look that information up. So this is a recreation of page 1 of your notes. The 2 videos ago you took notes on addition and subtraction, and the essential question was how can you evaluate simple equations, and you took notes in this space right here. And then you wrote some questions the last time you watched a video for each chunk of your notes. And now we are ready for the bottom section, which is the summary. Now the summary, when you're writing notes, when you're revisiting notes, is the answer to the essential question. And the essential question is, how can you evaluate simple equations? And so the answer to that essential question goes in your summary and is really just what you understand about what's in your notes. Now I might write something like, I can evaluate simple equations by adding, and then I would write more, but I don't have room and it'll take forever, but that's a good start, and you can start with that one too if you want. Really, that summary is the answer to the essential question. And once you write that summary, you will have interacted with your notes 3 times, which means you have a great deal more possibility of remembering what's on that page. The first time was when you took the notes, the second time was when you wrote your questions, and the third time now is a summary. You can actually interact with those notes a 4th time by covering up your notes and asking yourself the questions that you wrote in that margin. This is how you understand what's in those notes. And when you understand what's in notes, you remember more, and so you're more successful on tests. That's how it works. The brain works on repetition. And by taking notes this way, we've built into this class at least 3 opportunities for you to repeat looking at your notes. Now turn to the next page. On page 2 of your notes, the topic was addition and subtraction rules, and the essential question was, what are the rules of addition and subtraction? And again, you took some notes, yeah? You got some notes here in this part? Now it's time to write some questions in this column right here. You're going to want to take a look at the chunks of notes that you have, and you're going to write some questions about it, a lot like you did with that other page. And you know, it's okay if you don't come up with a lot, but if you happen to come up with a lot, that's even better. And then leave the summary part blank because, you know, we'll get to that later. So you might want to pause the video now and just sort of review your notes. Write your summary on page 1, and then write your questions on page 2. And when you're done with that, start setting up page 3. Because here comes page 3. I believe it's page 3. I hope that's what we're on. Anyway, here's your essential question for the day, and here's your topic. Now remember, the topic goes at the top of the page, and the topic today is multiplication and division. And then the essential question goes below that. How do you multiply and divide integers? Now make sure that you go back to your table of contents, and right under where you wrote addition and subtraction rules, you write this topic, multiplication and division. And then out to the right of that, put a 3, I think, because I think we're on page 3, but I might be losing track already. So now you have one full complete page of notes on page 1. On page 2, all you're going to have to do is, after you get done with your questions, you're going to have to write a summary, but we can do that later. And on page 3, you have this topic and essential question. Now divide page 3 up to make a place for a summary and a place for questions, and let's get ready to take some notes. So today we're talking about multiplication and division, and as you know, there are 4 basic mathematical operations: addition, subtraction, division, and multiplication. We've talked about addition and subtraction. Today we're going to take on both multiplication and division. That's my phone ringing. That's fun. All right. Anyway, multiplication is the thing we're going to talk about first, and multiplication is really kind of like repeated addition. If you wanted to look at what 3 times 4 means, it's really the same as adding up 3, 1, 2, 3, 4 times. 3 plus 3 plus 3 plus 3. Now that's the same as adding up 4, 1, 2, 3 times. 4 plus 4 plus 4. All of that is 12. And it's easy when things are small, like 3s and 4s, to just add things up. But when you've got really big quantities, multiplication is a way to pull together large groups of information. Now there's some vocabulary that goes along with multiplication. A factor is the numbers being multiplied. A factor is the number that's being multiplied. So in our example right here, 3 and 4 are actually factors. We can write that here. 3 and 4 are factors. And then we have a product. A product is the answer when you multiply. The answer when you multiply. When you get to the answer of a multiplication problem, it's always called a product. When you add, it will not be called a product. When you multiply is the only time that you will have a product. And so in our example, 12 is the product. Okay? So you have factors, that's the 3 and the 4, and then you got 12, which is the product. All right. Now, I've sort of talked about this in the warm-up, but what does multiplication look like? Well, multiplication can look pretty familiar. You guys are probably used to seeing that symbol right there, meaning multiplication. And then we talked a little bit in the warm-up that potentially you could see multiplication look like that. It could be an asterisk. And sometimes it's a big old dot. And sometimes it's parentheses. And sometimes it's brackets. And guess what? Sometimes it's nothing at all. And we'll see that when we get to things that look like that. That little term says 3 times x. In fact, it might be better if I say this way, because maybe that x is confusing, and that's why there's a lot of symbols for multiplication, just so you know. How about I do that? That says 3 times y, but notice that there's no symbol there. When there's no symbol, we have to assume multiplication. So multiplication's tricky, and it makes us a little bit crazy. Because you have to interpret multiplication problems. But it's okay. With enough practice, like anything, you get good at it. All right, so we can do a couple together. I mean, this is not going to be too terrible. 4 times 2, you know that's 8. 10 times 5, you know that's 50. 12 times 7, well, that gets a little bit trickier, but it's still not too bad. When we know things are simple, like 4 times 2 and 10 times 5, we can do those quickly in our heads. Go ahead and do that. But when things get slightly trickier, like 12 times 7, it might be worth remembering to stack them. There's actually a lot of ways to multiply, and I suggest that you look up things like Russian peasant method of multiplication, or there's one where there's like these, I don't know, you might have seen it on YouTube or on Facebook. I think it's like a Japanese multiplication method where they do like stuff like that, and then they count up stuff. I don't know. It's pretty cool. And I actually know how to do it, but we don't really have time right now. But you should look it up, because there's some really great ways to think about multiplication. But in American schools, in the United States, and other places too, we teach you to stack them up. And so that's what I'm going to keep with for now. So then you start at the bottom and you go 7 times 2. Well, we know that's 14. And so we're going to drop the 4 here and carry the 1 up here. And then 7 times 1 is 7 plus 1, which is 8. And you get the answer of 84. Does that look familiar? Gosh, I hope so. Now, 17 times 82 is very much like 12 times 7, but we just have to do things more than once. Again, we're going to start with this number right here, furthest to the right and on the bottom, and we're going to multiply up. So we have 2 times 7, which is 14. Carry that 1. And then 2 times 1 plus 1. 2 times 1, which is 2, plus 1, which is 3. Now, here's the part that makes people crazy. Oh, I have to put my pen down, I guess, to erase. And I don't blame you. But once you've multiplied by this 2, you're kind of done with it. You don't have to do anything with it now, but you do have to remember to drop a 0, because you have to push the other set of numbers that you're going to use for the 8 over a little bit. So now the next step is to figure out what 8 times 7 is. Anybody remember? It's 56. So you drop your 6 and put your 5 up here. And then 8 times 1 is 8, plus 5, 8, 9, 10, 11, 12, 13. And now you're going to add them. Do you remember how I said at the beginning that multiplication was just repeated addition? That's why you add in this case, because we're just using addition kind of secretly with multiplication. At this point, you're just going to add these two numbers up. You get 4 plus 0 is 4. 3 plus 6 is 9. And then you have this 3 plus nothing up here and 1 plus nothing. And so there's your answer, 1394. Now again, there's all kinds of ways to multiply. I'm teaching you the stacked method because it's probably reminding you of the stacked method because it's probably what you're most used to. But there's a lot of ways to multiply, and it can be really fun to explore those alternate ways. And maybe we'll do that together sometime, but for now you can look them up. All right, let's get into division real quick. Now, just like multiplication is kind of like repeated addition, division is kind of like repeated subtraction. If we take 12 and we subtract 4 from it, we get 8, correct? And then we subtract 4 again and we get 4, and then we subtract 4 again and we get nothing. How many times did we subtract 4 out of 12 in order to get to nothing? Well, the answer was 3. And that's how division can be like repeated subtraction. And when we do division, you're going to use subtraction in it because it's sort of like subtraction in disguise. Just like multiplication, there is some vocabulary. Excuse me. You have the divisor. Oh, let me mention this. When we look at division like this 12 divided by 4, we can also write it like this, and this is kind of like confusing to people. You actually end up switching. So you have 12 divided by 4, and what looks like 4 and then the 12, but they're both saying the same thing. 12 divided by 4 on top, 12 divided by 4 on the bottom, that's the same. Okay? Now, in our, let me draw my little symbols in there. Getting back to the vocabulary, the divisor is the number you are dividing with. And so in this particular problem, 4 is the divisor. It's the thing that divides everything up. And then the dividend is the number being divided into. All right, so in this case, the 12 is the dividend. All right, and then the quotient is the number, oh, sorry, not the number, the answer. When you divide. The answer when you divide. And so in our case here, the 3 is the quotient. Just like multiplication has a special name for the answer, the product, division is the same way. The answer is going to be called a quotient whenever you divide. When you're adding, the answer is called a sum. When you're subtracting, the answer is called a difference. Multiplication, it's a product. Division, it's a quotient. And those are nice little key words because they can tell you what's going on in the problem and what you need to do if you understand them. All right, we're getting close here. We're going to do a little bit of division problems. Now, division is a little bit trickier to understand, and we're just going to do it. But I have some tips. Getting through division is a matter of repeating these 3 things. Asking yourself how many times, and then multiplying, and then subtracting, and then doing it over and over again. And so what you're going to want to do is when you are dividing, you're going to look at, I'm just going to scribble it out for now, the first number. And you ask yourself, how many times can 2 go into 4? And the answer to that question is 2. And you could, yeah, answer is 2. And you could put that right up here. You put that right above the 4. And now the next step is to multiply. 2 times 2 is 4. And so you write a 4 down below. And then you subtract. 4 minus 4 is 0. So that's the first time through those steps. Oh, I'm trying to erase and I keep forgetting to put my pen down. Okay. Now We're done with that 4. We just want to look at the 6. We're going to look at each number one at a time, and we have to bring it down so it becomes the next step in our problem. And this 0 doesn't really matter. 0, 6 is still 6. And we ask ourselves, back to step 1, how many times does 2 go into 6? And it goes evenly 3 times. So I'm going to write the 3 above the 6. Next step is to multiply. 3 times 2 is 6. I'm going to write that below that 6. And then I will subtract, and I get 0. And now the last step. Oh, Miss Wait. Remember to put down your pen. Now the last step. Bring down that 8. And I actually do always draw that little squiggly line because I just like to. And then you ask yourself again, how many times does 2 go into 8? It goes 4 times, so you record that. You multiply that 4 that you just wrote times the 2 that is the divisor, and the answer is 8. And then the last step is subtract, and you ended up with 0, and that's great. Sometimes there's remainders. We can deal with that some other time. But notice that you have dealt with every single number that is under this symbol right here. And since you have, you're done with the problem. Okay? So let's speed this up a little bit. First of all, let's look at this for number 2. Get rid of those other numbers for a second. Does 9 go into 3? Not really. And so we have to look a little further. Does 9 go into 30? It sure does. We've got 9, and then 18, and then 27, and that's where you're going to stop because that's less than 30. You're going to have to keep that number less than the one that you're working with, and that's our how many times step. We know that 9 can go into 30 3 times. And so I'm going to write it above the 0 just to remind myself that that's the number I'm working with. And now I want to multiply. 3 times 9 is 27. And then subtract. And this time I'm going to get a number. 30 minus 27 is 3. Great. Oh, what did I do? There it is. All right. So now I'm just going to look at that 6, and I'm going to bring it down. Now I have 36. How many times does 9 go into 36? Well, it turns out it also goes in 3 times because we have 9, 18, 27, and we have to kind of stop there to stay under 36. 3 times 9 is 27. And 36 minus 27 is what? Well, 27, 28, 29, 30 is actually 9. Oh, I think we could have put that 9 in another time. Oh my gosh, you guys, I made a mistake. That's okay. I think I did that in the last video too, huh? Oh, it's been a while since I've done these things, but look at me not die from making a mistake. Making mistakes is actually how we learn. And the reason why I'm distracted while I make this video is because my phone keeps going off and I don't know what's going on. So forgive me. Let's go back. So let's see, what have we done? 3 times 9 is 27. We subtracted, we got 3. So we're not dealing with the 9 yet, and we're bringing down the into the 36. Now it seems to me that maybe 9 times 4 is actually 36, huh? Yeah, I think it is. Is it? Boy, I'm starting to doubt myself now, you guys. 9 times 4. Okay, yep, it's 36. Holy mackerel. All right, well, that's fine. We have 36. Subtracting, you get 0. And now we're going to deal with that last number. How handy. It's a 9. Now, how many times does 9 go into 9, y'all? I bet you I get this one right. It's 1. Am I right? Oh, I hope so. And then 1 times 9 is 9. Subtracting, you get 0. Ooh, okay. Shall we try number 3? Maybe I'll get this one right. It's tens, so tens are a little easier. So again, when we're looking at this and we look at that first number, we recognize that 10 can't go into 7. It just can't do it. And so we have to look at the next number. And how many times does 10 go into 75? Well, in order to stay below 75, it's 7 times. So that's our first step. And then our next step is to multiply 7 times 10, and we get 70. And then we subtract, and we have 75 minus 70, or 5. So now we're going to take a look at the next thing. Bring in that 9, drop it down, and we want to ask ourselves, how many times does 10 go into 59? Well, in order to stay below 59, we got to say 5, because 5 times 10 is 50. And we're going to subtract now, and 59 minus 50 is 9. And now we deal with our very last number, that's 0. Bring that down, and 10 goes into 90 9 times. 9 times 10 is 90, and we could subtract, and there you go. All right, well, I did better on that one. Division, that's how you do that, and hopefully you remember those steps, and if not, we can always talk. So I have one more thing for you before I wrap this up. Sometimes we have to multiply or divide positive and negative numbers. And I have a way to remember that may be just a little bit mean, but it's kind of funny. So when you take a positive number and you either multiply or divide it by another positive number, you always get a positive number, okay? When you take a negative number and you multiply it or divide it by a positive number, you always get a negative. When you take a positive and multiply or divide by a negative, you always get a negative. And then the last possibility is if you take a negative number and you multiply or divide it by another negative number, you always get a positive number. And what you might notice is that when signs are the same, like this and like this, either both positives or both negatives, you always get positives. And when signs are different, like in these two cases, you always get negatives. And that's one way to think about it. But I have something that is kind of funny that will help you remember even better. At least it helps me. Whenever I'm multiplying and dividing, I think about it this way. I remember a little, I don't know, it's not a poem, it's just a little thing that helps me remember. So here's how it goes. So positives are good and negatives are bad. Let's just say it that way. When good things happen to good people, that's good. When bad things happen to good people, that's bad. When good things happen to bad people, that's bad. But when bad things happen to bad people, that's good. Maybe that's a little bit mean, but it helps me remember. Whenever you're multiplying and dividing, these rules are going to apply, and so there's something to know and a little way to remember them. All right, friends, well, that's all I have for you today. Our topic was multiplication and division. Your assignment is a quizzes, and it's on Google Classroom. Just click it and get that work done. You have a week. The essential question is, how do you multiply and divide integers? Can you answer this? If not, you should let me help. There's office hours, there's our class time. I'd love to help you. All right, you guys, I hope you have a lovely day, and I will talk to you next time. Bye.